So in this video we're going to have a look at how you would construct half equations from first principles. So in this case we're not going to have our overall equation, we're not going to have an ionic equation, we're not taking something back apart to find the half equation, we're going to build a half equation from some information. Okay, we just need to make sure that we remember that you can't just balance the atoms, you have to balance the charges, and that's where our electrons are going to come in. So some simple ones, we need to remember what a bromide ion is. So think about what a bromide ion is, and we know that a bromide ion is a Br minus. And then what is bromine? Well, remember our diatomic elements, and bromine is one of them. So step number one is to balance those atoms. So I'm going to need to put a 2 here. And then step number 2 is to balance our charges. So if you can't see it immediately, think about the left-hand side and the right-hand side. At the moment, on the left-hand side, I've got 2 bromide ions, which have no charge. -1 each. And on the right-hand side, I've got no charge from the bromine molecules. Now, all I can do to make charges balance is add electrons. And electrons are negative. So I need to make both sides be the same. And the only thing I've got is negatives to add. Now, since the left-hand side adds up to -2, I'm going to need to make the right-hand side be -2, because all I can do is make the numbers go down, because I've only got electrons. So I need to add 2 electrons to the right-hand side in order to balance the charge. And is that then, say to yourself, does it answer the question, is that an oxidation? Well, yes, because we've lost electrons. So our next one, it tells us we want to go from Fe3 plus to Fe2 plus. So at the moment on the left hand side we've got 3 positive charges, and on the right hand side 2. And remember, we can only add electrons, so we can only make the numbers go down. So we're going to make them both sides equal to 2 plus by adding 1 electron. Reduction is gain. So there's some straightforward ones. What about some more complicated ones where there's a few more steps? And these rules here are really important. Okay, so write out the formulas for anything you've been told and balance the atom undergoing redox. Now, if anything ever gets missed by students, it is that step there, balance the atom undergoing redox. Then, your next thing to do is add water to balance the oxygen. So balance oxygen by adding water, then balance hydrogen by adding acid, H plus ions, and then last of all, charges by electrons. So in the ones above, we were doing the first step and the last step because we didn't need to balance anything else. So we were just skipping from first to last step. Let's have a go. Conversion of nitric acid. So we know that nitric acid is HNO3. So this is step 1, write down the formulas for the reactants and the products. So if you can't do this, you need to go back to the introduction to chemistry and make sure you're familiar with formulae. And nitrogen dioxide. So I've written down the formulae. I need to balance the atom undergoing redox. Now, you get a bit of a feel for redox after a while. Which element is likely to be the one changing? And it's very likely to be the nitrogen, because we know that oxygen's quite often it's mostly -2 and hydrogen's +1. So we check that there's the same number of nitrogens on each side. And there are. So we move to the second step. Balance oxygens by adding water. So at the moment we've got 3 oxygens on the left and 2 oxygens on the right. So I need to make there be 3 oxygens on each side. So I think, how many water should I add until there's going to be the same number of oxygens? And by adding just 1 water, I've got 3 oxygens on each side. The next rule is balance any hydrogens by adding H+. Now at the moment I've got 1 H on the left and 2 on the right. So I need to add 1 more to the left. So I'm going to add a H+ to the left. And now I need to balance the charges. And there are no charges on the right, but a 1+ charge on the left. Now remember, all you've got is electrons, which are negative, and they are going to reduce positives down. So I need to get +1 down to nothing, because the right hand side is nothing. So I am going to be reducing nitric acid. Now, as you get better at redox, you'll start to be able to think about, does this make sense? the nitrogen in this compound is +5 oxidation state, and in this compound it's +4. So how many electrons would you think you'd need to add to go down 1? And is it the right number? I've got 1 electron there. So let's have a go at these questions, following the rules. Rule number 1, do I know what chlorine gas is? Do I know what chloride ion is? Chlorine gas has been turned to chloride ions. Now I balance the element undergoing redox. 2 Cls, so I put a 2Cl, that's rule number 1. Rule number 2, I don't need to do because there's no oxygens. Rule number 3, I don't need to do because there's no hydrogens. So I'm straight on to balance the charge with electrons. Like that. Do I know my formulas? Sulfuric acid, sulfur dioxide. Balance the atom undergoing redox, it's going to be the sulfur. There are the same numbers. Add water until you've got equal numbers of oxygen. I've got 4 and 2, so I'm going to add some more oxygens to this side. How many more oxygens? 2. So 2 waters. Now I'm balancing the hydrogens. At the moment I've got 2 hydrogens on the left and 4 on the right, so I need 2 more on the left. And now I'm going to balance the charge by adding electrons. I've got 2 pluses and no charges on the right, so I'm going to add 2 electrons to the left. Now hydrogen peroxide may be a formula you're not so familiar with, but it looks like that, and that's oxygen gas. Have a go. So we didn't actually need any waters because the oxygens were the element undergoing redox and they were balanced, so we just added acid and electrons to the right hand side. So there are plenty more of these in your study pack. Have a go, get it out and have a practice at writing a half equation.